This is a project I made for my friend Doug, who recently had the challenge of making high-speed measurements of light intensity. And he didn't care exactly how bright the light was quantitatively in lumens or in something like milliwatts per square meter or whatever. He just wanted to know with high time precision when a light was getting brighter and when the light was getting darker. And I realized this with very low cost and low complexity and built the device that you see here. It's really simple. It just has an on-off switch and a power light to let you know when it's running. The batteries are inside. It has a light sensor here, which is a phototransistor, and then it converts the light intensity to a voltage, and it just sends the voltage out here. So this is a really simple circuit actually, and I'll describe the circuit diagram later. But first, let's show this device in action. So I've got my oscilloscope here. Let's get this all focused. And I have a BNC cable plugged in. And I'm going to plug the other end into the device. And when I turn it on, you can see a voltage appears on the oscilloscope. And depending on where I point it, let me zoom out a little bit. If I point it at the light, it's bright, and if I cover it up with my hand, it gets darker and it approaches zero. So even just moving my hand in front of it, you can see that the light changes. So if you're in a situation where it's dark and kind of quickly go like that, you get the idea. So if you're gonna make a high-speed recording, you can just record the output of this device. The output is between 0 and 5 volts. Actually, let's see, what is it? Probably 0 and about 4.5 volts, 4.8 volts. That's because there are some batteries in here. So let's take a look at the circuit diagram to see how this device actually runs, and then we can take a look inside the device. So the core of this device is pretty simple. It just has 3 AA batteries, which provide about 4.5 volts, we'll say. And there is a device called a phototransistor. So the symbol looks like a transistor, except it doesn't have any base. Instead, it has 2 little squiggly arrows to indicate that when light hits the phototransistor, it allows current to flow downwards. And if it maximally allowed current to flow downwards, it would be a short just from positive to ground. So we don't want to do that. We will add a current limiting resistor, and this is about 100 kilo ohms. The value of this resistor I just kind of guessed by looking at the output and seeing what looked good. If the value is too low, you won't get much swing with brightness. But on the other hand, if you want to measure really low intensity light, it would probably do you well to choose a really high resistance here. I actually don't know what the phototransistor is. I just found it in my junk box. And I'll bet you could actually use an LED for this purpose as well. It won't work quite as well as a phototransistor, but it would work. One other thing to note is that the phototransistor works with ambient white light. It's not an infrared phototransistor. Some phototransistors have a special material in the lens itself, so it only lets in infrared light, and that's great for a TV remote control, but it wouldn't do a good job accepting ambient light. So yeah, this is pretty simple. When light hits it, current flows down, so charge is able to build up here. And all I do is I take a voltage reading here, and just for safety, I run it through a 1 kilo ohm resistor, and then just pass it out in a BNC. And that's it. There's also a switch in there, and I think I threw in something like a 47 kilo ohm resistor with a power LED, just to let us know that the device is on. And then the actual switch, of course, is up here. So let's take a look inside and see how it was done. This is just a plastic enclosure that pops open. At least it should. Man, I added a little bit of hot glue to keep the battery pack in, so maybe the hot glue sealed it. Let's see. There we go. All right, there's the whole device. Really simple, hot glued, a battery holder with 3 AA batteries. The phototransistor is there, power switch, and the LED, and yeah, our resistors, 1, 2, 3, are in there. 1, 2, 3, and that's the whole thing. So altogether, we have a device capable of measuring light intensity. So we'll give this to Doug and hopefully it meets his needs.